All right, I'm going to do homework 2 as a video. I'm going to show you how to do these problems in case you had difficulty. So I'm just going to do it and watch this video, and this will show you how you should have done the homework. So if you got them wrong, you can check this out. So in the first problem, it says the sun is 22.5 degrees above the south horizon on the winter solstice. What is your latitude? So we're going to draw our Herb diagram. We always put north over here, south here, Herb in the middle. And then if we look at the problem, it says the sun is 22.5 degrees above the south horizon. So the sun is right here, 22.5 degrees above. Okay, but to figure out what our latitude is, we have to figure out where the North Celestial Pole is. It's going to be over here somewhere. But we know the North Celestial Pole is always exactly 90 degrees from the celestial equator. So we got to figure out where the celestial equator is. So whenever we find the sun, we figure out where the celestial equator is. But we know, we just have memorized that on the winter solstice, the sun is at a declination of negative 23.5 degrees, which means it's 23.5 degrees below the celestial equator. So I have to put the celestial equator right here so that this angle is 23.5 degrees. So the sun on the winter solstice is 23.5 degrees south or below the celestial equator. Now that I know where the celestial equator is, I just go 90 degrees from that. 90 degrees right here. And then I have to find this angle. This is the North Celestial Pole. This is my latitude. So if I add these two together, 23.5 plus 22.5, I get 46 degrees. So this is 46 and this is 90. Then what's ever left over from a 180-degree half circle is what is left. So I just take 90 plus 46 and I get 40 equals 44 degrees. So my answer is 44 degrees north. So the key to doing all these problems is, remember, you put the sun and you use the sun to find the celestial equator. Once you have the celestial equator, you find the North Celestial Pole. Once you have the North Celestial Pole, you find the altitude of it. That gives you your latitude. Okay, so this is problem 1. And the answer is 44 degrees north. Let's do problem 2. So in problem 2, it says, what's the altitude of the sun for someone who lived at a latitude of 51 degrees north? Okay, in this case, we already know where we live. So I can put in the North Celestial Pole because it tells me this is 51 degrees. This is the North Celestial Pole. Here's Herb, here's north, here's south. Okay, then I need to find the celestial equator, but I know the celestial equator is always 90 degrees from the North Celestial Pole, which if I do 180 minus 90 minus 51, I get 39 degrees. So this altitude of the celestial equator is 39 degrees. Okay, remember the sun is always measured from celestial equator. So when I know where this is, I can just figure out where the sun is. So the sun on the summer solstice is going to be 23.5 degrees above it, or on the summer solstice, we just add 39 plus 23.5, and you get an answer of 62.5 degrees. This is the sun on the summer solstice. On the equinoxes, sun on the equinoxes, the sun is right on the celestial equator. So on both equinoxes, the answer is just 39 degrees, or 39 plus 0 degrees. It's still 39 degrees. On the winter solstice, you take the sun, and the sun is now going to be 23.5 degrees below the celestial equator. So this is the sun on the winter solstice. And so I just take 39 degrees minus 23.5, which gives me 15.5 degrees. So those are your 4 answers. Remember, you do the equinoxes twice because the autumnal and the spring is still going to be at 39 degrees. All right, number 3 says the sun is 47 degrees above the south horizon. So this is just like problem 1. South, north, 47 degrees right here. Here's the sun. And what day of the year? It says the sun on the summer solstice. Well, we remember that on the summer solstice, the sun is 23.5 degrees above the celestial equator. So if it's above the celestial equator has to be down here, 23.5 degrees away. Okay. Then from the celestial equator, I go 90 degrees. Remember, I always go 90 degrees from the celestial equator. Don't go from the sun. The sun moves around the sky. Celestial equator does not. Here's the north celestial pole. I need to find this angle right here. Well, first I have to figure out what the altitude of the celestial equator is. But I know this is 47, so I just take 47 minus 23.5. And if you do that, you get 23.5. So this is 23.5 degrees here. And then I have 180 minus 90 minus 23.5. Leaves me with 66.5 degrees north. That is your latitude, and there's a very special name for that. That's also known as the Arctic Circle. That's how you do number 3. Number 4. We're going to do a 3-dimensional diagram here. So here's our circle here. Here is north, here is south, east is back here, west is here. And it doesn't really matter what latitude you're at, so we're just going to put it at some arbitrary position here. This is the north celestial pole. Celestial equator is always 90 degrees away from that. It makes a perfect half circle that goes east and west. But we know on the summer solstice, the sun is at plus 23.5 degrees. So the sun is going to be 23.5 degrees above the celestial equator. The sun on the summer solstice. So it's going to make a path along the sky that goes like this, because it's going to be 23.5 degrees here and here. So it's actually going to rise here. It's going to set way over here. Well, if you look, here's east and here's north, so it's actually rising in the northeast, and it sets in the northwest. So the answer is northeast, because we asked where is it rising? Right here. On number 5, the question is, how much daylight do the following occasions aren't received on June 22nd? And this one refers to this diagram. You watch the lectures, where during the summer solstice, this is straight up, the poles of the earth, or the north pole of the earth, is tilted towards the sun. So the sunlight is coming from this direction here. And since the earth spins like this, spins around the poles, this is the Arctic Circle. Everything from the Arctic Circle up to the North Pole is going to get sunlight all day long, because the sun can go all the way across. So this is all going to get 24 hours. So if you're on the North Pole, you get 24 hours. If you're on the Arctic Circle, you get 24 hours. If you're at the South Pole, sunlight only gets to here. You're in the darkness, and so the South Pole gets 0 hours of daylight, even all the way down to the Antarctic Circle. Still only gets 0 hours of daylight on This is the summer solstice, June 22nd, approximately. Okay. Remember the date of this wine's around some years or something like that, but let's just call it the summer solstice. And then the other one is the equator. What we have to realize is when you're on the equator, I do it as a herb diagram. If you live on the equator, the celestial could go straight over your head. The north celestial pole is here. South celestial pole is here. This is on the equator. And the sun will rise over here in the summer solstice, but it still goes straight up and straight down and makes exactly half a circle. So the answer is 12 hours. In fact, on the equator, you get 12 hours of daylight every single day of the year. It never changes. You never have long days, you never have short days. Every day is exactly the same. So not much variety if you live on the equator. So those are your answers: 24, 0, 24, 0, and 12. And that's how you do homework number 2.